Cool. All right, everyone. Good morning, DerbyCon. Um, Happy to be here. This is a bittersweet moment. I'm really excited to be speaking for the second time at DerbyCon, but also really sad that it's the last one. Um, I have to say that definitely for me, DerbyCon was, the best con. I've met so many good people. Some of them I met for 10 minutes. Some of them are still my friends, but they're all cool. And I'm going to miss that. So DerbyCon, I'm going to miss you. We hope we get something similar. Okay, so I'm going to start. So my name is Mauricio, and today I'm going to be talking about adversary simulation and all the benefits that adversary simulation has to provide to detection engineering programs. In fact, I think adversary simulation is so important for detection programs that I chose this title, which is from the French mathematician Descartes. He said, "I think, therefore I am." So I simulate, therefore I catch. Because I think that without adversary simulation, we're not really doing detection the right way. And hopefully, I'll be able to support this throughout this talk, and you'll think this way too. So today I have three main, let's say, areas of the talk. One, we're going to do like a quick introduction of just what's simulation, what's detection engineering, and what are the challenges with detection engineering, how simulation can help those challenges. Then we're going to go over some recommendations from my perspective to you guys. If you're thinking of integrating adversary simulation to your programs, I'll give you some tips, some things that we do that may you be able to replicate. And finally, I'm going to be releasing a tool today that we've been using internally to build, test, and enhance detection. So hopefully you'll be able to use it and help you on your detection programs, okay? So just a little bit about me real quick. I'm originally from Arequipa, Peru. That's a picture of my home city. We have a big volcano called El Misti, and you can see the El Misti volcano from pretty much everywhere in the city. I currently live in New York and lead the threat management team at financial services in New York. That's my Twitter account, and I always love to connect and meet new people. So come say hi if you see me. That's my GitHub where the tool will be uploaded. So my first DerbyCon talk, I started the talk with a fun fact about Peru. So I kind of want to use this to break the ice again. So I'm going to drop a fun fact about Peru. All right. So who here likes or liked punk rock at some point? Yeah. So me, as a teenager, I really liked punk rock. I got into it through a friend, and I really liked the music, the mosh pit, the rebelling against authority, your parents, school. But I still like the music a lot. And when you read about punk rock in its origins, you always come back to these two bands, the Sex Pistols and the Ramones in 74 and 75. But locally in Peru, going to the local bands and the local concerts, I always heard about this band called Los Psychos, which actually was from 1964, so 10 years before the Ramones. And their music was really something similar to punk rock. I grew up thinking that the Psychos was maybe one of the first punk rock bands. And in fact, a few years later, there's a few media outlets that started talking about this, and a few rock historians, I guess, or were talking about this. So yeah, that's the fun fact. Punk rock may have started in Peru. And if you want to know more about it, you can check this documentary. All right. So we'll go ahead and start. Cool. So I wanted to start this talk by talking about where are we as a blue team in 2019, from my perspective. So the first, go blue team. So the first point that I want to make is in 2019, blue team understands that prevention has fallen short. It's not going to work. There is no one single tool that is going to be able to stop all the attacks. As much as machine learning and AI and deep learning they have, it's not going to work. It just doesn't work, right? And we understand that we need to be improving detection. That doesn't mean that we shouldn't deploy prevention controls. They have a room in the whole security program, but once we deploy the basic security foundations from a prevention perspective, we should be focusing on detection. The next point is we assume compromise. So we know that attackers are going to get in. It's not a matter of if, it's when, right? But I think that shouldn't demoralize us, because getting access, getting an initial foothold, it's only the beginning, right? It takes some effort and steps to be able to achieve operational success. And the attacker doesn't know your environment. We know our environment. So we kind of use this on our advantage to build an environment where we can set traps in the environment and catch attackers as they're doing their operation. We are logaholics. We understand that attackers are going to get in, and we need to detect them. And to create detection programs, we need data. So we're bringing all these data in, host data, network data, application data, right? And we're centralizing it to an event pipeline going to your central location. This could be as simple as a SIM, right? Or this could be more complex as a data lake in Apache Spark, you name it. It could get really complex, but really simple. But at the end of the day, we have the same. We have all these data, and we have some kind of analytic platform so that we can run queries on, right? We now use this data to develop custom analytics. So we're no longer just deploying tools and waiting for them to work and alert and do something, right? We're going into our data and creating these analytics based on our environment, custom to us, that will help us detect some patterns of attacks, right? And also in 2019, we speak adversary, right? I feel that the MITRE ATT&CK framework is a really great tool that gives us one single taxonomy that we can use to measure programs based on actual techniques that attackers use in the wild. And it also allows us to collaborate between other blue teams because we're speaking the same taxonomy, right? Okay, so I feel that also in 2019, the blue team is building the attacker's playground. And I borrowed this term from Jessica Payne, who wrote a blog post in 2017 about this. And she mentioned 4 main principles. And it's I highly recommend you go and reading this. However, I'm not going to talk about that particular, the way she sees it. I'm going to just use that, the term, and kind of explain it from my own view. So as we've talked about in the last 5 minutes, initial access is only the beginning, right? And it takes effort and time and several steps for an attacker to achieve operational success. And these steps, this process provides us detection opportunities. And what I want to mention in this talk as traps. The more traps that we deploy in our environment, detections, the more likely for an attacker to trip one of them. And they only need to trip once, and we may catch him, right? And you probably all heard this phrase. As I started my career, I always heard it. Attackers only need to be right once. Defenders only have to be right all the time, right? Well, I'm telling you, we're turning the tables. Now, defenders only need to detect once. Attackers just need to make one mistake, and we'll catch him. Because remember, the goal is not to prevent the initial foothold. The goal is to prevent operational success. And we can catch him as they're trying to get to that goal, that target data. And I think that a big part of the attacker's playground is detection engineering. And from my perspective, detection engineering is the continuous process of deploying, tuning, and operating detection analytics with the goal of finding threats, right? So we're using all these data that we're gathering from our host network application data and building new detections, enhancing them, testing them, making sure they're operating, they're working. And this is how I see the attacker's playground, right? We have a combination of both prevention controls and detection controls all over our environment, right? And all this data is being centralized to an event pipeline to your SIM, your data lake, whatever it is that you may have as that central location. And we have a few important steps like ingestion, transformation, where we're standardizing that data to make sure that we can query it the right way across multiple data sources. We're indexing, and then we have some kind of analytic platform that allows us to run queries on these data and create detections, right? This is important. Without this, we have no detection programs, right? So this is kind of like a prerequisite. And the way I see it, as we build the attacker playground, as we build on our detection engineering programs, we look something like this, where we're setting all these traps in the environment. And as you can see right here on the lower left, an attacker may get an initial foothold. Sure, but they need to get operational success and grab data from the data center maybe. And as he's doing the attacker is doing the operation, he may trip one of our traps, and it only takes one, and you have a proper process. We may catch him before they achieve success, right? However, I think that detection engineering and the attacker's playground have a lot of challenges, and I want to talk about 4 challenges. The first challenge is, you have a bunch of prevention controls, which makes sense to have, and we should have. But how do you know if they're working? When was the last time you checked that your firewall is blocking 22 outbound? Or when was the last time you checked that your proxy is actually blocking certain categories, right? Or is your anti-malware solution blocking the right things, right? Second challenge is, we have all this data. Awesome. How do we build detection if we don't have proper attack telemetry, right? How do we know what's a known bad, what's a bad pattern? Number 3 challenge is going to be detection resilience. How do we know if that one detection that you have or that one attack technique is really resilient and is going to detect all the variations of that same attack? You may have a full sense of coverage if you think, yes, I have detection for credential dumping. But what if the attacker uses a different technique instead of reading ELSAs, right? And the last one is, how do we know there's always changes on our environment, right? Firewall changes, reboot windows, patching. How do we know if one of those changes didn't break our event pipeline in some way, right? What if your branch office in Singapore has somehow gotten a bad firewall rule and is no longer sending events to your SIM? All these challenges, I feel, can be approached with adversary simulation, right? Just simulating attack techniques to make sure that, that the event pipeline is working, that your detection is resilient, and that your process is being followed. So your SOC is properly following the process. So I think I'm going to focus on 3 goals. Confirm prevention controls are working, generate the attack behavior telemetry to build, test, and enhance custom detection, and finally, identify gaps and visibility, right? Those are all the ways that I feel adversary simulation can help you in building your attacker's playground and in deploying detection engineering programs. But how? Sure, Mauricio, this makes sense. How do we do this? So I want to give you some tips of a few things that we do, and hopefully they make sense to you and you can implement it. I think that the very first thing that you want to do is make sure that your prevention controls are working. I'm not going to focus too much on this because this talk is about detection, but what I would recommend doing is just go to your, go to a whiteboard and just start enumerating all your prevention controls at the host level, at the network level, and prioritize them. What's most important for you? And then come up with simple ways of testing this. It doesn't have to be too complicated. It can be manual initially. IPS, you can do a wget to a particular URL with a particular path that it has to, it's going to trigger a rule and hopefully block it, right? Or memory protection, you can invoke Mimikatz from a high privilege PowerShell shell, and it's going to work, right? So, test your prevention controls, make sure they're working. But if we move to detection, this is kind of the process that we use to build the detections. So first, you identify the technique of interest. So this could come from, the MITRE attack framework. This could come from a threat report that Mandiant releases from a particular threat actor that you're interested, or this could come from a tweet from Matt Graver on something that he's, playing with in the weekend. Of course, this technique has to be of interest to you, right? It has to be some kind of importance to you. The next one is you design the simulation scenario. So in this phase, what you're going to do is just learn more about this technique, really understand it, understand the scenarios and how it can be implemented, and then figure out what tool are you going to use to simulate it. Can you use an open source tool? Do you need to write your own? Is it even possible to simulate this, right? Then once you figure that out, you're going to execute that simulation. You assess coverage, see if you have that. The most important question to ask is, do I have centralized telemetry for this type of simulation, right? Because if you don't, you have to go back and correct that visibility. This could mean a GPO change because you're not logging a particular event ID, or this could be a new span session from your firewall because you're not sniffing that part of the network, right? So you go back, you figure out how to correct that visibility gap, you execute the simulation again, assess coverage, now you have the data in, and you ask yourself, do we have a detection for it? The first time, you probably won't have a detection for it, but at this point we're good because we have all that data, so we can compare that known bad pattern with the known good. So you can hopefully build a detection analytic and create a detection for this. You go back, simulate, and then you now have a detection trigger, which is good. However, I don't think you should stop there. You shouldn't assume, okay, I have a detection for this technique, I'm done, let's move on to the next technique. I think that we need to validate detection resilience. This is really important. I think that the same technique we need to be able to simulate in different ways, because that technique can be implemented in different ways by attackers, and then that may look different on the logs, and you may have a false sense of coverage. And let me give you a simple example: password spraying attack, right? Let's say your purple team or your red team runs this tool against you, this password spray attack by DAF hack, and you're running it from a Windows domain join host from PowerShell. When you do this, this is actually using Kerberos and trying one password per user, right? And you make it easy to create a detection based on that, based on the 4771 event ID, which we're gonna take a look at in a little bit. So you may think, okay, I'm done, password spraying, I got this. But what if we do something like this, where you're no longer using a Windows domain join host, you're using like a rogue device in the environment that has got some kind of physical access. You're not using NTLM, sorry, you're not using Kerberos anymore, you're using NTLM, and you're no longer targeting the domain controller, you're targeting like a server. So this looks completely different on the logs, right? And that first detection that you had for the first one is not gonna work. So that's why I think we need to be simulating different variations of the same technique. Another important thing that we use simulation is to measure detection maturity. So we came up with a maturity matrix, if you want to call it like this, for each simulation, each detection. So as we build our detection, maturity level 0 is the simulation does not generate events. So this is where we have no data, right? We cannot detect this technique. So we need to go back and enable logs, enable network sniffing, or maybe buy a tool because you don't have visibility, right? It could be anything. Maturity level 1 is when the simulation generates events, but they're local. So we cannot use them we cannot use create detection for this because they're local on that host. So we cannot use them for a detection program. They need to be centralized. Maturity level 2, simulation generates events, and they are central in a central location, but there's no detection for it. So this is when we need to go and build that detection. And finally, simulation triggers a detection, which gets you in a better spot, a maturity level 3. And maturity level 4, the simulation triggers a detection, but also triggers the proper response process. I think this is important. Simulation doesn't only help us test if the detection is working and is resilient, it can also help you test if the whole process is working. You know, is your SOC elevating the right level of critical alerts to the right place, right? Are they doing what they're supposed to do? Are they following the playbooks? And you can do this with simulation. And I couldn't get this this morning, but imagine a nice graph where you have detections and maturity across time. This could be something cool that you can show to your management, right? And one thing that we do is we have weekly validation tests, and we have our junior analysts go through this validation test and go through each one of the detections that we have mapping to attack, or sometimes not. We do this weekly, and we put that maturity level on that for that week, right? And as we go through time, as your detection engineering team is fixing these visibility gaps, is fixing these detection resiliency issues, you're gonna get better and better, right? Yeah, and the next step that you wanna do to take it to the next level is definitely start using automated adversary simulation frameworks and tools like Atomic Red Team, MITRE Caldera. I wanted to go deep, go into this a little bit, and then as I was searching online, I found this really cool talk which actually takes these three and just analyzes them from different perspectives. So I'm going to point you to that to kind of learn more of the atomic rate or mitochondria. This is a really cool talk from this year. So now I want to talk about my tool and what we've been doing. This is what we've been using internally to test, to build, test, and enhance our detection. And hopefully it's going to help you do the same. Okay, so this is kind of like the next version of a previous tool that I wrote for besides Baltimore. Called Purple Spray, which is focusing on password spraying. But now I moved from Python to C# to kind of be more native. So these are the requirements that I had as I was building this tool. So I want to simulate TTPs, right? But I don't want to focus on atomic things like running MSHTA or running regsvr32.exe, right? I want to focus on behavior, right? So that was one requirement that I had, behavior simulations. I want to implement the same technique in different ways, as many as I can, so I can make sure that my detection is resilient to all these variations of the same technique. I want to target random hosts on the network. This is really important, right? Because this is going to help me identify visibility gaps. If I run a lateral movement technique against the same server every week, are you really testing your coverage, right? What if that small branch office in Europe that you have somehow is not properly sending your events? The only way of knowing that is simulating attacks against random hosts and making sure that the events are coming in from any host in the environment, right? So this is really important. So that's why my tool needs to pick random hosts always. It's not weaponized for now. So, for example, even though I create a remote service, I don't start it or execute it. I just create it and delete it, right? But eventually we can make it more to the red team. Where possible, use Windows API calls, because this is kind of a selfish requirement. I just wanted to learn more about using Windows API calls from C# using platform invocation services. So I wanted to see what simulations I could do with Windows 32 APIs. And then I wanted to have one single binary, no extra infrastructure. So there's not going to be a C2. It's just one single binary that I can drop and just double click on. It's going to execute a random technique, right? Doesn't need extra anything else. It doesn't even need to have parameters as username and password, because if you run it in the context of a user, it's going to grab that user context and do the LDAP queries. So I don't need to pass passwords or put passwords. Okay, so this is, and I call this Purple Sharp. So this is a beta. So right now, this tool executes adversary behavior with the purpose of generating known bad telemetry, right? To help you build, test, and enhance your detection. I'm mapping my simulations to the attack MITRE framework. I think I support like 9 or 10 simulations now. So basically, even in my code, I use the attack tactics. It's in C# .NET 4.5, and the code is up actually right now, so you can play with it. So let me walk you through some demos. Now, when I did my first DerbyCon talk, my friend Jason Lang helped me on the talk, and he told me, hey, you need to tell a story. So I want to tell a story about Purple Sharp. So, and every story has a character. So I needed a character. So I was going online, just let's see what kind of character I can get. And I found this book, Bob and the Cyber Llama. So yeah, I'm going to use the Cyber Llama as my character. Okay, so here's the story. The Cyber Llama just got a job starting the detection engineering program at Acme. Okay, Acme has spent the past 12 years building the attacker's playground. So the Llama doesn't have to come in and make sure that events are coming in, the event pipeline, the analytics platform, that's all done. So the Cyber Llama, all he has to do is just create detections. And the Cyber Llama has heard about adversary simulation and Purple Sharp. So let's see how the Llama is going to use Purple Sharp to create detections. All right. So the first thing that the Cyber Llama is going to do is going to go back, take a look at the pentest report from 2018, and just see what techniques were implemented by attackers. And this is not all the pen testers did last year, but this is some of the techniques that the Cyber Llama wants to create detections for. So let's go over that. So attackers got in through a phish. They did some password spraying. That got them some accounts, but nothing privileged. So they moved on to the next technique. They did a network share enumeration, just looking for open shares. That got them something interesting. They found a folder with a web.config file in it with some creds. So then they used these creds to execute the privilege enumeration technique, which is just spraying that account across the domain and seeing where that account is a local admin, right? But that didn't get them anywhere. So they went ahead and did a curve roasting attack. And then that got them an account. They did a spray again, privilege enumeration. They found that that account was a admin on a few hosts. They moved laterally using WinRM and WMI, and they got access to the target data, right? So, okay, let's simulate this with the Purple Sharp. So how can Purple Sharp help us do this, okay? So Purple Sharp supports simulating password spraying attacks, okay? And the way I see it is I broken down password spraying into two categories. The first one is what I call local domain spray. So this is when the attacker is just validating credentials on that host and just talking to the domain controller, right? He's not talking to other hosts in that network, right? So for this, I use this Windows API, logon user. Now, the two cool parameters that I want to use is logon type and logon provider. So the logon provider actually allows you to pick if you want to use Kerberos or NTLM, which is pretty cool because I can, iterate and run different simulations using Kerberos or NTLM just to see how the logs look like right? If they look different at all. The second one is logon type. I'm not using it right now, but I think it's pretty interesting because this logon type parameter actually maps to the logon type of the 4624 event ID. So you could actually, and this is interesting for red teamers maybe, because you could actually fake a network logon without actually being a network logon, because you can just put type 3 there, and the 4624 is going to have 3. So it is interesting. I don't know why they would expose this, but I'm not using it right now. I just thought it was interesting. So the second spray that I call it the network domain spray, and this is going in no longer against the domain controller, but actually going against hosts on the network, right? And spraying them like a server or a workstation, spraying accounts against them. And for this, I use this Windows API. And this Windows API is used to map network shares. So I just use that to try to authenticate. And if it works, the credential is valid. Now, the important parameter here, I think, is the resource, because if I put the FQDN, it's going to use Kerberos, and if I use the IP address, it's going to use NTLM. So once again, I can play with those different variations using Kerberos or NTLM to make sure that the detection is resilient, right? Okay, so all right, so a spray attack needs to target users, right? So I wanted to have different ways of targeting different users. So I have different parameters for targeting different users. So what I call neighbor domain users or foreign domain users. So what I do is I create the logon server, so the domain controller where you are authenticated to, and I use this LDAP query to grab users. Make sure that the bad password count LDAP attribute is lower than 3, because I don't want to log accounts out. And also last logon, because I want to target active users, not disable users or old users, right? And I also use this LDAP query to just take out any disabled accounts. So I want active accounts. So the neighbor domain users, I go to the logon server and I create this query. For the foreign users, what I do is I get a list of all domain controllers. I randomly pick one domain controller and grab those. So that way I can target users that may not be on your same region. They could be logging into different domain controllers. So I just wanted to see if that makes any, if it's a difference, it's a different variation. Just want to target random users, right? I also can target disabled accounts. This could be interesting because what if the attacker has had access to all disabled accounts and now he's trying them, right? If you have detection for someone trying to use disabled accounts, that could be interesting, right? So why not build a variation for this? Password spraying against disabled accounts. Sensitive groups, I use this LDAP attribute to get a list of users that are either domain admins or part of the protected users group. So they're probably admins. And finally, I use this LDAP query to get domain admins. And this is a cool one, random users. I want to generate authentication events for users that don't exist in the environment. Why? Because once again, attackers, they make a mistake. They may make a mistake. What if they're trying a user list from another victim or something else? So once again, this is a trap, right? We're setting all these small traps in the environment, and hopefully if they make one mistake by maybe using a wrong user list, we'll catch it, right? Okay, and then how do I target hosts? So if you remember, I want to target random hosts in the environment. So I have the same concept. I use this LDAP query to make sure that hosts are alive. And domain neighbors, once again, I just grab the login server, so that domain controller where I'm authenticated to, and just get a list of servers. And then foreign domain neighbors, what I do is just grab a randomly picked domain controller and I ask that question. So in that case, I'm going to be able to grab targets from a random network in my environment, right? From maybe that small branch office or that small data center, I can grab any target randomly, always randomly. Random server host, this one I don't like that much, but basically what I do is I grab a randomly picked domain controller, I grab the IP address, and I just attack that class C, so the neighbors. I assume that the domain controller is always going to be on the server range, which may not be right, but I thought that why not this one? And then network neighbors, I do like that, this one. What this does is just queries the network interfaces, calculates the subnet, and then grabs the network, your network neighbors. So that way, if I run my simulation tool in my branch office, it's going to target that same office, right? Okay, so password spraying. Let's see how this works. I have a few parameters here. I'm not going to mention all of them. The most important is for the network domain spray, I have type 1 and type 2. So type 1 is what it's going to do is going to grab a random host and spray it. But so just one. And type 2 is interesting. What it does, it's going to grab 10 users. You're going to grab how many users you want, right? Let's say 10. 10 users. It's going to grab 10 random hosts, and it's going to authenticate one to each. So one user per host, so like a distributed spray attack. I wanted to see how that looks, how different that looks on the logs also, because that could bypass your detection, right? And I also support like a sleep. If you want to do like a slow attack, for example, you can pick the number of users. So anyway, let's go to the first demo, and I cannot see the screen, so hopefully you'll see what I'm showing. Let's see demo 1. Okay, you see this? Can you see it? Cool, thank you. All right, so I'm purple sharp technique local spray, number of users 5. So, and it just gives you some data of targeting, who's targeting the domain controller. And it's just gonna give you, one thing I like, it gives me the timestamp so I can go back and correlate to my logs when this happened actually, right? So it's trying Kerberos and it gives you the error code. So one cool thing, if I run this again, it's actually gonna target different users, right? Because I've always randomizing to minimize the risk of locking someone out, right? So as you can see, this is using Kerberos. So if we go to the logs, the Cyber Llama, now this is the Cyber Llama doing this, right? So the Cyber Llama runs purple sharp, goes to the logs, goes to the domain controller, finds interesting events, 4771s. And this happens when someone tries to get a TGT and fails with the wrong password. So cool, we can use this event to create a detection for password spraying, right? So that's an easy one. But once again, what if the attacker uses NTLM? So in my case, all you have to do is /prod2, and it's going to use NTLM. And then in this case, I'm going to use different users 5. So I think that's domain admin. So yeah, it grows domain admins from LDAP, it gets them, and it tries to authenticate with one password using NTLM. If we go to the domain controller, now we see something different. We don't see 4771s. We see 4776, which is the event that gets generated on the domain controller when an NTLM authentication is used against an account. And you don't get an IP address anymore like the 4771. You get a source workstation name, which is, it still works, but I think the IP would be better. But we can still use this to create a detection, right? So we have 2 types of detection so far, right? So now we're going to do something interesting. We're going to use a different type of user here, and we're going to sleep 2 seconds. Why not? So it's going to wait 2 seconds between each authentication event. And in this case, we're targeting disabled users, as you can see. So if you remember what I said is, I want to create this detection because I think it's interesting who's using disabled users in my environment. I want to know. I think this is an interesting detection. It shouldn't happen that often. And if it's happening, something's broken probably, right? So in this case, you see a 4768 and the result code of 12 hexadecimal. So this is interesting. We can use this correlation of events and result code to see who's using disabled users. And finally, I'm going to use random users just to see how that looks like on the logs. So I do that, generate 5 random users. It generates, now this is a bug on the code. It's supposed to create different user every time, but I didn't want to go through the demo again. So I'll fix that. But anyway, you go back to the logs and now it looks completely different. You see a 4768. But the result code this time is 0x6, right? So once again, I've learned a lot from Kerberos events, from an NTLM event. So let's move on to the demo number 2 for network spray. So if you remember, network spray is going to spray not longer the domain controller, but random hosts in the environment. Okay. So I'm going to use protocol 2 for NTLM. It's going to randomly pick a host, in this case, Windows 10-2, and it's going to spray it with 5 users, right? Okay, that's cool. So if we run this again, once again, always random and with a sleep. The tool actually targets this time a different host. It's going to target, if it comes back, you see how it targets Windows 7-1, right? So it's always picking random targets. So if we go back to the logs, this is NTLM. So what you see on the logs on the hosts, no longer on the domain controller, what you see on the logs of this Windows 7-1 is you see 4625 events. And 4625 gives us the source IP address, the user, the source workstation. So this is a cool event that we can use to build detection, right? I'm going to fast forward a little bit. Okay, this is type 2. So this is the distributed attack, right? So you're going to see on the logs how the purple sharp is distributing the attack and testing one user per computer, right? In a distributed way. Because that may look different on the logs. That may bypass your detection. So why not simulate it, right? Okay, all right, here's a really cool thing that I learned recently, is that on the host where the spray is originating, right, you see an interesting event, 4648. And this event happens when you're trying to use explicit credentials to authenticate, right? Now, this event is really cool, but because it gives you the user that tried this and the user that you're trying to authenticate as. And it also gives you the host you're trying to connect to and even the port that you're trying to connect to. So it's pretty cool. So now we can use a detection on the receiving end of the attack, but also on the origin. So you can detect if a computer is infected through this detection, right? So it's pretty cool. So we can build detection for this. So I'm going to fast forward because I think I show what I wanted to show. Go back to the slides. And okay, so takeaway. The Cyber Llama really understands event logs now. We know what happens with Kerberos. We know what happens with NTLM. I'm not going to go through this because we don't have enough time. But you know, we are now understand how authentication works. Looks on the logs, right? And the Cyber Llama has a few new detection analytics. It's going to use the 4771 to detect Kerberos-based local password spraying, 4776 to detect NTLM-based password spraying, and why not the 4768 with result code TRX12, which is going to trigger if someone uses disabled accounts, right? I really like this one because that shouldn't happen on the environment. Yeah, and then also we've learned that non-existing accounts also create its own type of result code, and my tool is able to simulate that. So maybe this is going to be too many false positives because users are always going to type in their username wrong, and that's going to generate this type of event. But maybe you can create a baseline, and maybe you can use this as a detection potentially, right? But this should not go into production because it generate a bunch of false positives. Okay, and going back to the 46 for the network spray attack, now we're going to use 4625, log on type 3, grouped by the source network address, the IP address of the attacker, where unique account name bigger than threshold. So we have one extra detection on 4625 and one again for 4648, which is going to detect from the origin someone spraying accounts across the network. Now, we've also learned something interesting on 4648. We have the target server name, the IP address, the target port. So maybe there's 2 extra detections that we can build at some point. You know, event 4648 and subject username different than target username. This is interesting. When is a user going to use different credentials to authenticate? Maybe your sysadmins will, but is Anna from HR ever going to have a second account? Probably not, right? So that's another trap. And this is a cool one. What if you create 4648 and the computer account is not the administrators group, and the user that they're trying to authenticate is an administrator. So why would, and again, Anna in HR try to use the domain admin credential, even if it doesn't have the password? So that's an extra detection, right? What if the attacker makes a mistake and types in the wrong password, and we can catch him, right? So okay, so let's move on to the next simulation. How are we on time here? Okay. Network share. Okay, so I use this Windows 32 API netshare enum to enumerate network shares. And the privilege enumeration is when an attacker wants to know if he's a local admin on that remote host. So I use this Windows 32 API, which is the same API that Power View uses for the commandlet find local admin access, I think it's what it's called. So, all right, demo 3. So this case, boom, okay. Cool, so we're gonna use network share enumeration. We're gonna pick random hosts, and it's gonna successfully enumerate the shares. It doesn't print them back, it just enumerates them based on the Windows 32 API result code. I'm gonna purge the Kerberos tickets. All right, here's something interesting that I learned. So it's doing network share enumeration, a bunch of hosts, right? But here's something interesting. When you're doing this, when you're trying to authenticate to several computers, you're actually gonna get a service ticket and the service name is the computer account. So this is interesting. As an attacker or as a sysadmin is going to authenticate to a bunch of hosts using Kerberos, it's first going to get service ticket for all those computer accounts and then connect to the servers. So we could use this as a detection as someone's trying to spray or authenticate to a bunch of hosts, maybe moving laterally or running Bloodhound, right? So that's a cool one. And I also see a 5140 file share access, and you get the IP address, and then you get this share, IPC $sign. So this is when you're enumerating the shares. So this is another way that we can detect this. I'm going to move on, kind of go a little fast forward here in the interest of time. So privilege enumeration. So what this is going to do is going to call that API to make sure that if I'm an admin or not in this host. As you can see, this user is an admin on a couple of hosts, not all hosts. If I run against the entire environment, I find like I'm an admin on a few hosts. So if you go to the logs of this host, you see another event, 4656, and a handle to an object was requested. And in this case, it's going to be really easy to detect because the object server is SC manager, service control manager, and the access mask is what we sent on that request on the parameter for the Windows API call. So you can use this as a detection when someone's trying to enumerate where their local admin's in, right? So CyberLam is happy. Now we have more detections. We can use that 4769 to detect when someone's trying to access several hosts on the network. We can use that 5140 to detect when someone's enumerating shares across the network. And we can use the 4656 to identify when someone's trying to enumerate privileges on a host. Now, one thing that I like is this is really similar to how Bloodhound works, right? Bloodhound is going to connect and make API calls to all hosts of the environment. So when Bloodhound runs, it's also going to get 4769 service tickets for all your domain hosts, and then connect to each one of them. With these two events, this is how we catch Bloodhound, at least on the the default parameters. Okay, and last demo. This is for Kerberos and lateral movement. It was playing. Okay, so Kerberos, and for this technique, I'm not using Windows 32 APIs. I'm using Rubius from Will, from SpectreOps, and I'm just basically copying his code. Thank you, Will. And you can sleep, a few seconds if you want to make it like a slow attack. At some point, I also want to add a different version of this that's going to just Kerberos 1, not all of them, but that's just a simple variation that we can add. And this is easy to catch. This is a 4769 service ticket, and where the service name is no longer a computer, but the service name is actually the service account that associated with that SPN. So we can create a detection for this, easy. All right, so this is remote service. So this is actually going to use the create service API to connect to a host and create a remote service and then delete it, right? So as you can see, this user is admin on a few hosts, so he was able to do that. So if we go to the logs on a few hosts, you'll see this super legit update service created, event 7045. So we can simulate if an attacker is doing like PSexec or Metasploit PSexec, right? Without weaponizing it. So we can create a new detection for that. And my tool also simulates WinRM and WMI, lateral movement. So this is WinRM. I'm using just .NET here, not Windows API calls. And I'm going to execute notepad.exe, and I'm going to run this on a few hosts. As you can see, it's going to, let me see. So it finished here. Because it's not a local admin on this host, it cannot do it. And you can see how you see the Notepad process. At some point, I'm going to show it here. Oh, there you go. No, I think I had it there. Notepad running, and its parent process, it's always going to be that WSM prop host, which is the parent process for any child process of PowerShell remoting. And WMI finally, to kind of wrap things up, how are we in time? 44, cool. WMI, I use .NET once again, and I can pick ipconfig as the command. It's going to, in this case, I'm running as the domain admin, so he's able to execute everywhere. And you can see how he creates that ipconfig process, and its parent process is WMI prbsc.exe, right? So, wrapping up, almost wrapping up. Good, we went through all demos, that's good. So more detections, right? For Kerber hosting, you can use 4769. For new services, 7045. So yeah, at the end of the story, the Cyber Llama has 11 new detections in production and 4 in baselining for testing. And the Llama has learned a lot of Windows event logs and how authentication works and how they map to the simulations. So pretty cool. So this is just a mapping of what the tool can do with the attack MITRE framework. The ones that I grade, I put in orange is because, you know, the technique T1110, it's actually called brute force. There's no technique for password spraying. Now, I think that they're going to do sub techniques soon in MITRE. So I'm thinking that password spraying should be a sub technique of brute force, right? So another interesting one is that the technique privilege enumeration, where an attacker is just going to host, authenticating to them, trying to see if he's a local admin or not. That technique doesn't exist in MITRE. So so that'd be cool if they had that, right? Because I feel it's an interesting technique that attackers are going to use, and it makes sense. Then I can use lateral movement, persistence. Yeah. So all right, what's next? So what I want to do next is pretty cool. This is where it excites me, actually. I want to run a random technique on a random host at a random day and day and time once a week, right? That makes sure that my detection is working. Not only my detections are working, my pipeline is working, and also my process is working. So my SOC is escalating the right thing. So I want to get to this point. And how do I get here? Basically, I need a way to deploy Purple Sharp randomly on the environment, right? So I took a look at GPO, HCCM. They don't really do randomizing of, so I'm sure that some other tools do, but what I'm doing now is actually some EDR solutions have live response, which is basically a free shell. So I'm using our EDR's API to run this on a random host, for example. Now, something important is that the tool needs to run on the context of the logged user. I want to simulate a victim clicking on a link, getting popped, right? So how do I get there? If I run through that API call through my EDR, I run my code in a context of system. But just after one Google search, I found that it's really easy to, if your system, just to list all the processes and just duplicate a token and get your process as that user. So that's pretty easy. It can be done. It's actually already code written online that I found. And I want to implement some OPSEC also, because I feel that my SOC, if they see an alert from that same host, from that same binary every time, they're going to know something's up. So here's what I want to do. I'm going to randomize the file name. I'm going to use parent process spoofing technique. You know, the create process API allows you to pick your parent process. So I can pick Explorer or Chrome or Firefox to simulate an attacker, a victim clicking on something. And command line spoofing also, so that I don't have to pass all the command and the EDR won't see that, right? So closing survey for the blue team. You know, how do you know if you can do you know if you can detect a possible stealth network spray attack? Boom, that's how you know. Simple answer. Do you know if your SOC will escalate an LSAT's read block? You can just run this and you'll know. And can you identify a host executing remote code commands using WMI on your network? Just use this and you'll simulate safely. I want to wrap up with, as I was doing this, I mapped Windows 32 API calls to attack MITRE techniques. So I want to keep working on this. I think this makes sense. I think it's going to add some extra value to the simulation that I'm doing. And yeah, that is it. Right on time. Well, thanks for coming. I don't know if I have time for questions. A minute or two. Any questions? Yeah. Yes. Okay. Good question. So the code is on GitHub, but all the techniques that it supports are probably currently not on the README because I was at DerbyCon, and so. But you'll see all the documentation on the GitHub on the README probably this week. But the code is there. But yeah, I'm gonna work on that next. Yes. Yes, I'll release it on my Twitter account. So yes, later today, yeah, for sure. All right.